Hello everyone, welcome back. Let's have a look over our new accelerometer that will be BMA250, and to get your hands on the code and the sensor, let's first of all visit the website that will be controleverything.com, and after that we have to search on, as you can see, BMA250, and here we are. As you see, it's a digital triaxial acceleration sensor, and some of the more features which are mentioned like this: on-chip motion trigger interrupt controller, and the range is here, and some of more features. Also, you can purchase the sensor right from here. Also, I will be interfacing the accelerometer BMA250 with a BeagleBone Black, and C code language code will be applied. And let's go to the source tab, and here we have the C code sample onto the screen. You can download the code sample from this website as a zip file right from here. Also, you can get the code from github.com, and the concerned repository there will be Control Everything community. Now let's have a look over the code, and before that, let's proceed with the hardware connections. Well, for the hardware connection setup, the first thing we require is the BeagleBone Black, which you are able to see on my screen. And this here is an I2C Shield for the BeagleBone Black. Now this is available on the website controleverything.com, and the real reason we are using this shield is to make connections easier with other I2C devices. So for that, what do we require is to gently place this I2C shield over the BeagleBone Black and make a connection just like that. For the power up setup, we require two things. The first is a mini USB cable just like this, and gently insert it over here. It is very useful to power up the BeagleBone Black. Now, to power up the I2C Shield, we require a 5-volt adapter, which you are able to see on my screen, and gently insert it here. Now, for an option for the internet connection, there are two mediums. The first is an Ethernet cable or a LAN cable, and the second is this, a wireless nano USB adapter. Next, we need our digital triaxial accelerometer that will be BMA250, and here it is, and this comes a connecting cable. Now make the connection among the cable and the sensor, and make sure that the ground terminal of the sensor should be connected to the ground wire of the cable, and similarly to the I2C shield. Now what we require next is to have a look upon the code, and let's proceed. Now let's have a look over the code, and for that we need to log into github.com, and after that we need to pursue on the search that will be for the repository Control Everything community. Let's proceed, and here we are with the sensor. It's a BMA250 acceleration sensor, and here comes the C code. But before that, let's have a look over the instructions part. First of all, we need to set up our BeagleBone Black, and beaglebone.org is the link from where we need to install the drivers. The setup is here. Please do it carefully. After getting this, we need to download or pull the code onto the BeagleBone Black, and this command will compile, and this will run the C code properly. Now get back to the C code, as you notice, and it's a .c extension file. First of all, we have included some of the header files, as you notice, and in the void main function we have to check for the section in which I2C bus is going to open or not, and then we have to check whether the device address will be 0x18 or not. In the writing section part, first of all, we need to select the range selection register that will be 0x0f, and the command we are going to set is for range plus minus 2G, that will be 0x03, and here it is, the writing command. Then in the next writing command we are going to select the bandwidth register that will be 0x10, and the bandwidth we are going to set here is 7.81 Hz, that will be 0x08, and here it is. Then we have a delay or seal function of 1 second. After that we have a reading section in which we are going to read 6 bytes of the data for the acceleration for 3 perpendicular axes x, y, and z. Here, as you notice, we have the conversion of the data for 3 perpendicular axes into the 10-bit data. We have used some of the formulas which were mentioned in the data sheet for BMA250. At the end, we have the output data onto the screen, which you can see as the acceleration for 3 perpendicular axes x, y, and z. So this is how the code looks like. Now let's see how it works. Regarding the practicality of the code, the first step is to copy the entire code, as you can see on my screen, and we have to copy it, and after that we have to open up the terminal for the BeagleBone Black, and here you can see and here we have to create a new file. As you can see on my screen, it's a .c extension file, and after that we have to save the entire code, paste it first of all, and then save it. Now for the compilation process, this is the command for the reference. Let me type on the full command and this here, and let's see what we got. The code has been compiled successfully. Now for the working part, this is the command, and let's see what we got here. We have the acceleration in all three perpendicular axes, x, y, and z. When I run it again, we have almost the same value, which means there is no acceleration or not a motion into the sensor. But when I try to move the sensor in different directions and run the command, you can see the changes reflected onto the screen for the acceleration in three perpendicular axes, x, y, and z. And as you notice, as I'm moving the sensor, the changes are reflected onto the screen. So this means the sensor is working as per we desire. Now let's see what are the applications and some of the benefits and the features regarding this sensor. The BMA250 is a triaxial low G acceleration sensor with digital output for consumer market applications. It allows measurement of acceleration in three perpendicular axes, and evaluation circuitry converts the output of a micromechanical acceleration sensing structure that works according to the differential capacitance principle. The BMA250 senses tilt, motion, and shock vibrations in cell phones, handhelds, computer peripherals, man-machine interfaces, virtual reality features, and game controllers. Well, you can have this sensor and you can purchase it from controleverything.com, and you can get the code from resource tab. From this site, you can download the code as zip file. Also, you can get the code from github.com, and the repository there is Control Everything Community. In the end, I would like to make it clear that if you have any doubt regarding any part of this sensor or video, you can have your queries on controleverything.com, and you can post your comments on the community page on this website. For articles and blogs, you can have a look over on instructables.com, and to subscribe more video tutorials like this, you can have a look over our YouTube channel. In the end, I hope you enjoyed this video and had a good one yourself. Thanks a lot for watching.